Jackson online tutorial class. So I remain my humble self, Uncle Joshua. This afternoon, we want to continue with our physics tutorial class. And this afternoon, we will be looking into the cause of motion. So we will talk about force first. So if the time permits us, we move to friction. So far, we have discussed about motion. We've discussed about velocity time graph. And there is no way we are going to talk about the motion so without trying to talk about the causes of motion. That is, without talking about what brings about motion. And that is why we need to look into cause of motion, which is force. So we have been describing the motion of a body without regard to what causes the motion. Motion has merely been discussed in the term of displacement, velocity, and acceleration. So now we want to ask, why does a body at rest remain at rest? Why is the body at rest remain at rest? And a body moving with uniform velocity continue its uniform motion. What brings about that? Why is a body that you put at rest be at rest? And why is a body which is moving in a uniform velocity continue in uniform motion? So what will make the body at rest to move? And also a body moving with uniform velocity to change its state of motion. So a block of wood resting on the table will remain at rest until it is pushed or pulled by an agent. If I put this cup here on this table, without moving it, it will be here until a force is applied to it or push. If it doesn't, if the cup didn't push, so it will remain at the same position for forever. So similarly, a trolley moving uniformly along a plain, smooth, straight surface will continue this state of uniform motion in a straight line unless an agent pushes it or pull on it. So a body must react to something before it can move from its state of rest. So that thing that caused a body to move from its state of rest is what we refer to as what? Force. So such an agent that changes or tends to change the state of rest or of uniform motion in the straight line of a body is called force. It's called force. There's no way I can move this cup without applying force. If I don't apply force, I cannot even carry it up. So the cup will remain at a rest forever. But once some force is applied to the cup can move from its position of rest to another position. So an agent pull this cup from its position of rest to where it presently is, that is its destination. That agent that pull it is what we refer to as force. So for instance, now, when we hold the two end of a strip of rubber band and try to stretch it. So when we hold the rubber band and try to stretch it, so and also allow it to return to its original length. When we do this several times, we feel something. So you put the rubber band, then you're trying to pull it and stretch it and returning it to its former position. If you continue doing this, you feel something because you are not just pulling the rubber, you are applying something to pull the rubber, and that is what? Force. So a force can move a body, change its direction of motion, make it to slow down or stop moving altogether. So with the little I've explained, I can you can get to understand when we talk about force, what we are referring to. Let's move to the types of force. Let's move to the types of force. So we have two types of force. We have two types of force. We have contact force, and we have force field. Here are the two types of force that we have. Now let's look into what we mean by contact force and what we mean by force field. So when we discuss that, then we can quickly move to friction. And we explain friction, then the next thing is to start looking into some calculation that is in it. Okay, when we talk about contact force, what are we referring to as contact force? So contact forces are forces which are in contact or in touch with the body to which they are applied. I want to repeat again so you can understand. Contact forces are forces which are in contact or in touch with the body to which they are applied. Example are forces of push-pull, tension, reaction, and frictional forces. When you push something, so contact force, your body must react with the body you want to push. So that is what refers to as contact force. And this aids the body to move from its position of rest to where it is going to the final position or final destination. So that is what refers to as contact force. So let's look into force field now. Let's look into force field. Now, when we talk about force field, what do you need to understand about this contact force? So a force, a two body must come in contact before a body can move under contact force. So it involves body A and B. So before the body can move, so that is a contact force. Let's talk about force field. So force field are forces whose sources do not require contact with the body to which they are applied. So force field, they do not need contact to the body to which they are applied. Unlike the contact force, so they do not require contact with the body to which they are applied. Example are gravitational force and electrical force and magnetic force. So gravitational force, electrical force, and magnetic force are typical examples of force field. So what is gravitational force? So gravitational force is the force with which the earth attracts objects toward its center. So when the earth attracts objects toward its center, so we refer to a gravitational force. So that is the best that best describes is the law of gravity. So that is gravitational force under force field. So the force field group into three. We have gravitational force. We have electrical force, and we have magnetic force. This under the force field. So Now, with explained force field as a type of forces whose sources do not require contact with the body to which they are applied. There's no need to contact. So with the body by which they are applied. Now, what is gravitational force? Gravitational force is the force which Earth attract object towards its center. When Earth attract object towards its center, so we refer to it as gravitational force. So when Earth is trying to attract an object to its center, so the type of force that is applied there is gravitational force. So such kind of force does not really need the contact. So it does not need contact with the agent before it can move. So we refer to it as force field. Now we talk about electricity or electrostatic force. Now we just talk about gravitational. When Earth pulls an object to its center, that is gravitational. Now electrical or electrostatic. So electrostatic is the force that exists around charged bodies. So the force that exists around the charged bodies is what refers to electrostatic or electrical forces. So the force that exists around charged bodies is what refers to as electrostatic force. Now, let's talk about the magnetic force. Let's talk about the magnetic force. So magnetic force exists around a bar magnet. When you put two bar magnets or a bar magnet with an object, with a metal, so to attract, so for the forces to attract, it doesn't need a contact. So it doesn't need a contact before it can move. So it doesn't need a contact. So it's another example of force field. So magnetic force. So it is force that exists around the bar magnet. So the effect of such forces are felt by bodies which are not in contact with them. So their action are felt at what? At distance. So their action are felt at distance. And any force which action are felt at distance are regarded to as what? Force field. So force field. But if the force need body A and body B to come in contact, so it refers to as contact force. It refers to as contact force. So that is all you need to know about force. So that's all you need to know about force as one of causes of motion. Okay. So far, we try to look into what the force is, what causes a body to move. We've discussed motion, what brings about force. We try to look into force, and we try to explain the types of force. Let's talk about the friction. So, before we talk about, earlier we talked about the force as a cause of motion. Now, we want to talk about the friction. We want to talk about the friction. Now, we all know that when two solid material comes together and rub itself, so preventing them from moving freely, so preventing each other from moving freely, so the force of attraction that is happening between them is what we refer to as friction. But we try to explain details about friction now. When a solid is in contact with another, the roughness of their surfaces prevent them from sliding freely over one another. So such action is brought about by the effect of friction. introducing. If I take this cup without any other solid substances attached to it, this cup can move freely. It can move freely. Now, let me take another cup now. Try to join them together. Hold them tight. Try to move them. So you will see that the two surfaces are preventing each other from moving freely. So they are preventing each other from moving freely. So the action that brought about this effect, is what we refer to as friction. So the action that brought about the effect is what we refer to as friction. So friction is defined as a force which acts at the surface of separation between two objects in contact and tends to oppose the motion of one over the other. That is the normal definition of friction. Let me define it again. Friction is defined as a force which acts at the surface of separation between two objects in contact and tends to oppose the motion of one over the other. It tends to oppose the motion of one over the other. So that is friction. The force that brings about the action opposing each other, that is friction. If I rub two of my palms together, try to move them, hold them tight, try to move them, you see that one surface is trying to prevent the other one from moving freely. The force that brings about that action is what we refer to as friction. So let's talk more about friction so you can get to understand what friction is. So frictional forces act tangential to the surface of separation between two bodies in contact. So we can refer friction to as a force of opposition. So it is referred to as a force of opposition. So friction will never appear unless there is a relative motion or a force tending to produce motion. If a body, what they are trying to say is that if a body is at rest without anybody apply any form of force, so friction will not occur. Friction will occur when the body tends to move. So when a body, a force tending to produce motion, so then it always appears to oppose the motion or the force tending to produce motion. So another thing you need to know is that there are some frictional force that have to be overcome before an object can move over another. So frictional force also continue to act as long as one body moves over another. So when the force producing the motion is withdrawn, friction slows down the moving body until it eventually comes to rest. The effect of friction is brought about by the forces that is applied. If no forces is applied, so friction will not occur. This body A, this is another body B. They are resting on a plane surface. They are resting on a plane surface. So looking into these two bodies, there is a gap in between body A and body B. You cannot call this kind of reaction a frictional reaction, no, until a force is applied to body A or a force is applied to body B, pulling it so towards the other. Now, when it is pulled towards this body, and this one is also pulled towards the other, so there's a force of attraction that will happen in between them. So, and that is what? Friction. So that's what we call frictional forces. So that's what we refer to as frictional forces. Now, saying that, I think I've tried to convince you or to let you understand what friction is. So let us move to the types of friction. Types of friction. We do not forget, we are talking about the cause of motion. What brings about motion? What causes motion? So we've talked about force, we explained the types of force. So an example of force. Now we are talking about the friction. We've tried to explain what friction is and the example. Let's talk about the types of friction. So here we want to talk about two types of friction. We talk about the static. We talk about the static friction and dynamic friction. And dynamic friction. Now, static friction and dynamic friction. So looking into the types of the friction, we can try to explain or to understand what the static and dynamic frictions are. So static is stagnant friction, and dynamic change. It brings about change. So let's look into some example. So we can observe the effect of friction by attaching a spring balance to a block of wood and pulling the balance along a smooth board. When I'm trying to, in my next part, I'm trying to bring about so many practical materials that can best describe or explain the topics at hand for me. But for today, let me try to put the word down to every one of you understanding. Now, so we try to observe, we can observe, let's say that we want to observe the effect of friction. So we can observe it by attaching a spring balance to a block of wood. So when we attach a spring balance to a block of wood and pulling the balance along a smooth board, and pulling the balance along a smooth board. Now, let me try to illustrate this in the diagram. I'm trying to explain something. So let's know that this is our smooth board. This is our smooth board. So let's look into the weight. Let me assume that this is the weight on this smooth board. This is the weight on the smooth board. Okay, let's try to draw our spring. Not that good in diagram. Okay. So trying to draw a spring balance. This is another. Now, this go this way. Go this way, yeah. So here now, this is the weight of the body. Weight of the body. So this is our smooth board. This is our smooth board. Yeah, that's a smooth board. Here now, we call this place an effort. It is effort that we apply to this before the spring can be pulled, be able to pull the load, so all the body. Here is our spring balance. Spring balance. Yes. Now, here now is our frictional force. Now, what I was trying to explain earlier is what I just put into that sketch diagram. So when we try to observe the effect of a friction by attaching a spring balance to a block of wood and pulling the balance along, to a smooth board. So along a smooth board. So a force must be applied here. So an effort must be applied here before this spring balance can pull the body that is put on the smooth body here. And during the course of pulling the body, so there is a force of attraction that happens in between them. And the force of attraction that happens between them is what we refer to as, right? It's what we refer to as the frictional force. So that's that when we obtain a rectangular wooden block, so with broad and narrow side from our carpentry workshop. So one broad side and one narrow side of the block should be made as smooth as possible. So while the sides opposite to this should have raw surfaces. So place one of the board but smooth side on a smooth board. So I attach a spring balance to the end of the block. So pull lightly on the spring balance and note the effect on the block. Gradually increase the pull on the block until the block just begins to move. So record the maximum block for a force required to start the movement of the block by taking the reading of the spring balance just as the block starts to move. So this maximum force is called the limiting frictional force. Also, record the force necessary to keep the block sliding uniformly along the board. What am I trying to say? Let me explain it. So limiting frictional force. Limiting frictional force. So what is limiting frictional force? Okay, let's assume now that these two bodies, let me use this as an example. These two bodies were joined together. So we try to start moving it until they cross each other. So when they start moving it, so there's a force that I applied. There is a constant force so that I apply while moving this body towards another or opposite the other one. So there's a force that I apply. So, and that force is the maximum force that I can apply to move this thing, to move these two body surface over each other. So the force that I apply to move these two bodies over each other is what we refer to as limiting frictional force. No matter what, if you want to move the body, so there's a force that you must apply to it. That must be your limiting force. So because it's a frictional, so when the body is trying to be moved, you have to hold it tight while moving it. So the force that's applied is what we refer to as a limiting frictional force. Now, let me now talk about this. Let me now explain the static and the dynamic force now. Now, when we talk about static force now, static friction, sorry. We talk about static friction now. Static friction is the maximum force that must be overcome before a body can just start to move over another. The maximum force that must be overcome. So before a body can start to move over another, that is what we refer to as a static friction. A static friction, let me explain again, is the maximum force that must be overcome before a body can just start to move over another. Let me say this is a light object. As it is light, actually, if I move it freely, so there's a friction that is moving, that is happening in between them. So there's a force that I apply for these two bodies to move freely. So the maximum force that I apply here for this body to move over each other is what we refer to as static friction. Now, let us talk about dynamic friction. So dynamic friction can also be referred to as kinetic. It can also be referred to as kinetic friction. So we talk about dynamic friction. So it's the force that must be overcome so that a body can move with uniform speed over another body. Now, I'm trying to say so you can get to understand the differences that is between static friction and dynamic. So dynamic friction is the force that must be overcome so that a body can move with uniform speed over another body. A force that must be overcome so that a body can move with uniform speed. Force that must overcome. The force that you overcome for these two bodies to move in a uniform speed over each other. So the force that we overcome for this body to move freely over each other, that's what we refer to as dynamic friction. That we refer to as dynamic friction. Now, so what do you need to understand about friction? So what do you need, some fact that you need to understand about friction? I may be saying that when the class comes to end because we are moving too close to the end of the class. So, but no matter what, let me continue explaining what you need to understand. So about the friction. So friction opposes the relative motion between two surfaces in contact. So it opposes relative motion between two surfaces in contact. So that is what it does. So opposes a relative motion, so between two surfaces in contact. That is, it acts in a direction opposite to that of the motion. So it acts in a direction opposite to that of the motion. So it opposes the direction of the motion. That is friction. Another thing you need to understand about friction is the force of friction increases to the same extent. So as the force which tends to start the motion, the force of friction increases to the same extent as the force which tends to start the motion. The force that tends to start the motion with the force that needed for the friction to move, so are the same. So the force that moves this object from its position of rest and the force needed for this object to move freely in another contact, so are the same. So what you also need to understand is that so the frictional force depends on the nature of the two surfaces in contact. So it depends on the nature of the two surfaces in contact. That is the nature of the substances and the condition of the surfaces. So that is such as the rough, smooth, polished, wet, dry. So something that is smooth now, the way it will move will be different from the one that is rough and the one that is wet. So that is what we're talking about. Another one that you need to know is friction is independent of the area of the surface in contact. It's independent of the area of the surface in contact. So it moves freely. So it is independent of the area of the surface in contact. Friction also varies directly with the normal force pressing the surface together. The normal force pressing the surface together. So friction also varies. So with it. So those are the what fact you need to understand about friction. Now we will be moving to calculation aspect of the cause of motion in our next class. But before that, let me try to evaluate to review what have been explained so far. So we started with the cause of motion, and we talked about the force. So we talked about the force. So as is the term used in every discussion about the force, the energy that is applied to a moving motion, that the agent that changes or tend to change the state of rest or of uniform motion in a straight line of a body. So that is what it refers to as force. Now we talk about the types of forces, where we try to look into the contact forces and the force field. Now we explained that the contact forces are forces which are in what? In contact or in touch with the body to which they are applied. So they are in contact or in touch with the body to which they are applied. Example of such forces are forces of push, when you push something, when you pull. So you cannot push without being in contact, without coming in contact with the body. So you cannot pull without being in contact with the body. So that is contact force. Now, the force field, we talk about the force field. So, and we said that is the type of force whose sources do not require contact with the body to which they are applied. So they do not require contact with the body to which they are applied. There we explain, we said they are grouped into three. Such kinds of force are grouped into three. We talk about the gravitational force. We talk about the electrical or electrostatic force, and we talk about the magnetic. So, and we explain the gravitational force as the force with which the Earth attract object toward its center. So when the Earth try to attract the object to its center, so we said it is gravitational force. And we explain electric or electrostatic force as the force that exists around a what? A charged body. So that is electrostatic or electric force. So we explain magnetic force that they exist around the bar magnet. So that is all we try to look, or we explained about force. We talk about the friction. So, and we said that when a solid is in contact with another, the roughness of the surface, of their surfaces, prevent them from sliding freely, so over one another. So, and such action is brought about by what we refer to as what? By the effect of friction. And we now define friction as a force which acts at the surface of a what? Of separation between two objects in contact and tend to oppose the motion of one over the other. That is friction. We try to look into what, explain much about what the friction is, and we look into the types of friction, which is static and dynamic friction. So we try to explain what the static friction is. We say it's the maximum force that must be overcome before a body can just start to move over another. The maximum force that must be overcome before a body, if you look into it, before a body can just start to move over another. Why we explain dynamic? So as the force that must be overcome so that a body can move with uniform speed over another body. The force that must be overcome before a body can move on a uniform speed over another body. That is dynamic friction, so or kinetic. So that is that we try to explain what you need to understand about the friction. So what the friction is. So in our next class, we will be explaining the result of experiment that shows that frictional force is roughly proportional to the normal reaction. So between the two surfaces in contact, we look into F, which is proportional to R. So F proportional to R. So we look into that. We look into the coefficient of friction. We look into the coefficient of friction. So look at the different formulas. And the coefficient of friction is equal to the force all over resistance R. So or the reaction, sorry, forces of the reaction of the forces. That is what we'll be looking into. Then we look at some calculating aspects of the causes of motion. So with that, we can pause or we can stop for the class for now. If I should move on, so the time won't permit us. So let's just take our next class for a deep calculation on the cause of motion. If any of my students are online, so they are free to ask questions before the class come to an end.
Thank you, Jason, for that. Jason, do you have any questions? Edema? Jason?
I'm still listening if there's any one of them have any question to ask. And if they think they have any other one later, they can send it to my inbox.
Okay then. Okay then.
I will provide answer to every one of them.
Okay then. Thank you. Bye. Bye.
All right.